My name is Rhydian Benyon-Davies. I'm head of novel growing systems here at STC, and today I'm going to take you through our new vertical farming development centre here. So this centre was built for the optimisation and development of these new growing systems, sometimes called indoor growing systems, controlled environment systems, or sometimes vertical farms. As you can see, we have two chambers, which are exactly the same size, but can be controlled independently. They consist of racks which are 40 years high and 20 meters long. They have roll-on, roll-off benches in which we can grow plants and irrigate them all separately. You'll see a very pink light coming off some of these benches. The reason for that is that the LEDs that are lighting the plants consist mainly of red and blue LEDs. They also have a little bit of something called far red lighting as well. Now, the red and blue light is mainly there to target photosynthesis within the plant, and the far red light is there to improve leaf extension in the early growth of the plant, which then speeds on growth through the crop cycle. The idea with this facility is that we will have projects within here which conduct research into the optimization and development of these facilities. So part of these projects will be looking at how we optimize energy use, especially in terms of the heating, ventilation and cooling. We'll also be looking at projects which investigate new sensing technologies and how these contribute to the way that we manage plants within these facilities. These environments are quite unique environments in that we've decoupled all of the different environmental variables that we'd normally find in nature. So we have almost complete control over the temperature, the lighting and the day length, the irrigation, the nutrition, and also things like the airspeed within the facility. This means that we need to understand how all of these different variables interact. And so a lot of our work here is going to be looking at how all of these variables in different combinations affect not only plant growth, but pest and disease management within these facilities. One of the areas in which we've done a lot of work over the past 7 or 8 years here at Stockbridge is into the impact of light on plant growth, pest and disease management, and also how that interacts with other aspects of facility control. So light has a huge influence on plant growth and development. So different wavelengths of visible light have different impacts on crop morphology. For example, if you alter the blue percentage within the composition of a light spectra, you can alter the leaf flatness or curling in a plant. You can influence the leaf length, and you can also influence the concentration of certain compounds within the leaf of that plant. That will have an impact on the nutritional quality of that plant and the taste profile, but it'll also have indirect effects on how that plant is sensed by insects within the environment. So by altering the plant chemistry using light, we can also influence how pest and disease can impact different crops. You'll notice that we don't have any green light within this facility. Now, green light is important for crop growth, and contrary to what some people may have told you, it is actually used quite effectively for photosynthesis. However, green light penetrates canopies much more effectively than red and blue light, which tend to be absorbed in the upper layers of leaves. What this means is that the inclusion of green light really depends on what type of crop you're growing, in terms of the amount of self-shading within the canopy, and also the density at which you're growing those crops. So essentially, if you're growing at a high density, you might want to add a bit of green light into your light spectra so that you get a more even photosynthesis across the canopy. Commercially, these facilities have a number of different benefits. We don't use any pesticides within these facilities at all, which means that there'll be no residues and we don't have any impact on the environment. We can also recycle the water and nutrients that we use within these facilities, and it means that we don't waste any of them and they don't get leached into the environment. Also, we can control the microbial loads within the environment so that the crop, when it goes out to the consumer, has a very low microbial load and theoretically should have almost no pathogens on it going to the consumer. So the end goal for a lot of these facilities is to have crop which is ready to eat, doesn't need any washing, has a great shelf life, great nutritional qualities, and very good environmental benefits also.